Video, I'm going to introduce reactive programming using JavaScript using a library called RxJS, and it's part of this cross-language framework called Reactive X. So here are our choices in several languages. Before then, I'm already familiar with the asynchronous programming in JavaScript using promise, right? Um, but then I came across situation where I didn't see that promise is enough, you know, to handle the situation. So that's why I started looking at reactive programming. So what was that situation that I was having? So I need to process a stream of JSON and transform each one of them to a different JSON and save them to a file. Uh, I want to split those stream of JSON into multiple files based on uh, certain criteria. So in this case, I want to segmentize them based on the the hour. Yeah, I mean the JSON has the datetime information. So I want to group them. One I want to have one JSON file at the end for every hour for each hour. So why is that a problem? Um, I was thinking of because I could have done that sequentially. I mean, without even using promise, um, synchronously. I mean, but then many of the JavaScript library by default it's asynchronous using callback. For example, the file system library. It's so let's see the right file, right? Right file there. It's asynchronous. You will be notified about the status of your operation here in the callback. So um, so I can't really use the simplistic synchronous programming here, which is actually what I wanted because I want to process them sequentially as fast as possible. So this is like the reverse of the situation that we had in Java. I mean, yeah, Java in years ago when everything by default is synchronous, and we had to juggle around with threads, right? But here in I think in many new programming languages now it seems like the default is asynchronous. So whenever we need to do some synchronous operation, we had to to make some effort. So how is that a problem? I split that. Yeah, I want to make them. I, I want to make those JSON processed sequentially because I want to maintain the order, and because if I use okay, I have to use promise because if I use a simple promise and I want to sequence those because if I just spawn a promise for each line, so imagine I have like 10 JSON in the stream, and then for each one of them I create a one promise. Think of a promise like a thread for now. So you can create like 10 thread and you start you start all of them simultaneously. So you don't have the guarantee that those promises will be processed in the order they were created, right? So the trick when using promise is first to have those promise stored in an array, and then you chain them, using this. So first you have a array of promises. So this is your data, and for each uh, well, I how do I explain this? Okay, I have another example. So here, this is from my code. So here I have a list of URL it's from another project. So I have a list of URL to process here, and for each URL in the list, I turn them into promise, and so I have an array of promises here. And then oh, I'm not even using the reduce technique here. Here I just ask them to run all together, quote unquote, yeah, all those promises together. I said quote unquote because actually a JavaScript process is a single threaded. So actually there are no way that those promises will run at the same time. Uh, but still, you don't get the guarantee that those promises will be execute sequentially. So the trick here is using this reduce. So basically, you're chaining those promises. You see, because when you call a promise dot then, you basically it's like calling a thread dot start in Java. So dot then, and then you get as a return uh, you get another instance of promise, and then so you chain the then function. Yes. Okay, but it's not gonna work in this situation that I'm having, because I don't want to create like one. Let's suppose I have like, first it's a stream. We don't know how many JSON, how many items we have in the stream, so we can't really make a bounded array, right? Even if we know how many JSON there are in the streams, I don't want to create like 1 million uh, instances of promise in memory before I execute them using this. So that's why I turn my attention to this reactive X, with the hope, or maybe the thought, that uh, it's like a stream. So it comes in, you process that quickly, and then you get the output, and so on, like a stream. Um, so how does a reactive code looks like in JavaScript? So this is a very basic example. So uh, a streaming a reactive program will have an observable, and a subscriber, and then in the middle you will have like transformation. So yeah, this is like the source. This one, the source, the observable is the source. This one, what you have here, the function that you have here is the sink, and what you have in the middle is your pipeline. So that's basically what reactive programming is, I think. So this observable, I'm simulating here a source that generates events, like 3 events here, before calling complete to mark the end of the stream. So by calling subscribe, uh, your pipeline will start taking in whatever is pushed from here. So this JSON will go through the mapping, the transformation here in the map. So what I'm doing here is, making transforming the JSON that this one to this one or this one. All right. And then in the second mapping, I'm simulating the file operation, which is asynchronous. That's why I use the set timeout. So I'm combining with promise here. So yeah, that basically simulates the callback in the file operation. So here I'm returning immediately from this map. So it's like as if you're calling this file system write something, and then you have your callback here. Right? So it will return immediately from the concat map, from this mapping, and then will fall right away to this function, the sync. And here you get a chance to do whatever you want to do, maybe saving it to the database, or in this case, I just print them out to the console. So this one, this one is equivalent to this one, more or less. So I make a promise, I return a promise, which will resolve in this case 4 seconds or 1 second. That's to introduce some randomness here, some variations. Take that time. Set time out. Bam, bam. Observable. Oh, and this is I can't really explain that in detail now, but when you create a promise inside in your pipeline, you should return that promise wrap as an observable. So this function is a helper that turns a promise into an observable. So because this subscribe function takes an observable, this one create a simple observable that has a simple value like this, and this one will create a deferred observable. That's the way I think about it. There are you can make an observable out of promise like this one. You can also make an observable out of a callback. Where was that? Yeah, you can make it from a promise. You can create out of a callback. What else? You can create an observable like a stream out of an array of values, or you can create your own generator like this one, right? That's how you create an observable with RxJS. So let's try it. So what's the scenario here? We have even 1, 2, 3. They're created at this hours, but this event takes longer to process, like 4 seconds. So, but my expectation is that even though this one takes longer, the pipeline will not, should not jump into the third JSON. It should wait until this one is finished, has finished the processing, right? So let's try if that's really the case. Okay, so I print out in several places, but what we are interested in is this line. final outcomes. We have enrich data, enrich even JSON. 1, 2, 3. You see, it is indeed processed sequentially. Well, this is the key here, using the concat map. What if I use the flat map? Well, it still looks like a process sequentially, but that's just because we're lucky. Let's try again. Boom. Uh, Oops. I don't see that being jumbled. Uh, hmm. Give me a second. I'm sure I saw in one occasion, or several occasions, that they are inferred. Probably if I introduce more delay here. Okay. What? No. What the hell? Um. Hmm. 2. ID 2. Bam. Why? Hey. Why does it? Why is it finish in no seconds? It should wait for 10 seconds. Wait, what? Oh, there's a problem here in the code that it always falls to this, I guess. Even JSON. Let's see, even JSON. Oh, that's why. Oh, yeah, my fault. My fault. I forgot to add the ID. So that ID. Yeah, of course. Now you will see the problem if I use the flat map instead of concat map. Yep. Re. Yep. You saw that. Even number 3 is processed before even number 2. That's not what we want. So that's why we use concat map. What's the difference between concat map and flat map? Well, let's read the API. Where was that? Nope. Nope. Where did I read about it? Um, difference concat map and flat map. Surely I'll find it. What? Okay. There are lots of people asking the same question. All right. Here's. I think this is one of the better explanation. So take notes of the URL. So yeah, let's just take it for now that if you want a sequential operation, make sure you use concat map instead of flat map. Okay, the flat map. I heard of that term the first time when I program in Scala. So there's another thing called, okay, what's the difference between map and flat map? That would be the next question. Uh, let's suppose that you are processing array of array, but you want with how do you call if with map on the next stage of your pipeline you will get only two items, because you have in the input you have two elements in your array. But with flat map, you can flatten them basically. So let's suppose and the first element you have uh, one an array of one element. In the second element, you have an array of two elements, and so with the flat map, in the next stage, you will get three because they are flattened. So if you're familiar with I can explain that with Lodash, right? Uh, like giving a simple example. Flatten. Return. Well, flatten array of values. It's a blah blah. Yep. Let's try. Note. Why? That's a bad example. You could have made a little more interesting. Bam. What the hell? Oh, yeah. Okay. 10, 100, 20, 200. You're passing your array through mapping, a mapping function, and in the mapping function you get it returns an array, but you want at the end you want them, because without flat map this is what you would get. If you do this, bam, you get array of array. This one has the same elements, the same number of elements as this one. You have two here, and here you have two. But with flat map, it's different. So in the context of asynchronous programming with promise, like in Scala or here in reactive programming, it's a little bit different. The flat map basically unwrap the promise. So you don't want to get a promise of promise. You want to get you want to get to the inner core, right? So that's how the flat map works in the context of asynchronous programming. But the idea is the same. Concat map. Okay, if I use map, let's see what happens here. Oh, what the hell? Oh, this one. You see, here, instead of getting a JSON, I'm getting a promise here, promise observable, which is not what I want. So that's why I had to use flat map to take the value carried by the promise or promised by the promise, and that's what I'm interested in. I'm not interested in the promise itself, right? Okay, so that's the simplest example. What about the second example? Oh, this is subject. What is subject? It's a special type of observable. It allows you to produce uh, your your stream of data externally. So you don't have to put the code that generates the stream inside this block. You can put it anywhere in your code as long as it has access to the subject. So it's a generator, the same. Let's, so here I'm just it's the same scenario. I was just trying using the subject instead of a generator like in this one. So let's skip that. What about this one? Oh, here I am. Yeah, this is the concept of splitting the stream. You see, oh, actually here I'm doing the split. Yeah, yeah. Here I'm doing the split of the stream. So here you in the subject, it's one source of stream, but with subject you can have multiple, like a publish subscribe. Uh, is it public subscribe? It's a topic, it's like a topic. So basically, subject is a topic. Yeah, that's a synonym of subject. So with topic, you can have multiple listeners to that, and they will get the complete the stream, because there's another in messaging. There's another scenario, uh, which is pub sub, publisher consumer. In that case, if you have two two listeners, each one of them will only get some parts of the messages. So you need to switch to topic if you want them to get the complete values that are in the stream. So here I have two listeners. This, this is the first one, and this is the second one. The second one. So why am I doing this? So because I want a different types of processing. So each subscriber will treat the stream a different way. So I don't want to put it in the same code. I want to have them in separate module. So that's why this is useful. Subscribe. So what's the difference here? Oh, here in the first listener, I'm only interested in JSON of type interview. So that's why I'm applying filter. So basically, this pipeline, as the name implies, the transformation, it will transform the stream to another stream. The transformation uh, can be like mapping, or can be like filtering, like this one. So you limit you basically you take a subset of the original stream. Um, yeah. So this one only subs this subscriber is only interested in interview, and the other one is only interested in check-in. And so yeah, so it's the idea of splitting the stream. The third example is the same, exactly the same as this one, but I just made the code more like cleaner, because there are lots of repetition in the code. So I refactor them into one function like this one. Next, what is this? Oh, finally, finally, I'm trying with the 1 million JSON in the stream. I wanted to make sure that it's not going to create unbounded number, like huge number of promises in the memory. So because I thought that that's what reactive programming is all about. You 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 take one data from the stream, you process them as quickly as possible, and you pass it on to the next stage of processing, and once it's finished, you free all the resources that you use while during the processing. So uh, s- so that's why I try to verify that using this code, and I use things like this. This is the simplest thing that you can do, right? You run the program, uh, you run the program, and where is okay? First it's transpiling. Uh, Wait, be seeing I should be seeing these lines at, at some point. Okay, let's just wait a little while. Looks like it's buffering. So it's buffering for a couple of items in the stream before start kicking in. Yeah, you got it. Um, so let's check the first. Let me check the process ID. There you go. Man. All right. I don't see any increase in the memory usage, so I guess it's good. Of course, you shouldn't be happy with this profiling. You need to have to look deeper, right? So you can use HipDom. Uh, where is it? You can use this library. You install it. You have it in your code. This one line, and then to take the HipDom, you call this this comment. Okay, let me see, because I already got some HipDom. Snapshot, man. And now I'm going to take a fresh HipDom. Bam. Okay, it takes a while. Still taking. Still working. Oh, there you go, finally. Okay, so with HipDom, you need to take them multiple times. So you would wait maybe like 1 or 2 minutes before taking another HipDom. And then you open that in your Chrome Developer Tools. And let's see. And I'll take another HipDom now. Boom. This one, the first. It's still taking. Okay, finally. What the hell? How many? 100 megabytes. Okay. Load. It's the second one. I think I need a better tool here. We need a better tool, like profiling. We need profiling so that it takes a HipDom automatically every n seconds, and then a tool that helps us to see which objects it, whose number is increasing. The profiling tool. I don't see any profiling tool for Node.js. Well, yeah, there's some commercial offering. Uh, oh, I don't like App Dynamics. They have a profiling tool for Node.js. Uh, yeah, but okay, so we're just using the free stuffs that we can get from the internet. Cool. Okay, so this is the most basic one from Chrome. So what am I looking at here? Well, I'm not sure actually, but I suppose. Wait a second. Maybe this one? Object. Oh no, that's the simple object. Maybe subscriber. Subject. Okay, subject. Well, so at least we know that subject is something coming from this library reactive. So let's see. Now in the first hip down we have 8, and in the second we have man we have 8. Uh, 8. So it's not growing, which is good. But what else? What else should we need to check to confirm that with reactive programming we are being memory efficient? I'm not sure at this point, but the idea is you need to inspect the hip dump and see if there are any like memory leak or an object that consistently grows in numbers, right? But I don't see it so far. So I guess at this point we can conclude that uh, reactive programming rocks, right? So I like it. So far I like it. It makes me feel like at home, because I used to have that in Scala programming language. So yeah, so it's good to see that JavaScript is catching up with that. Okay, so that is all for now. See ya.